NASA's Juno spacecraft, which has been orbiting Jupiter for the better part of a decade, has just made its closest flyby of the innermost moon in the Jovian system. In this video, we will explore the new images of Io taken by Juno during its closest flyby in over 20 years, and we will learn how they could change our view of this fascinating moon. We will also discuss why they are so important and exciting. How did Juno manage to get so close to Io? What did it see and measure? And what does it mean for our understanding of Io's geology, volcanism, and interactions with Jupiter? These are the questions we will answer in this video, so stay tuned and get ready for a thrilling journey to the most volcanic world in our solar system. Io is the fourth largest moon in the solar system and the innermost of the 4 Galilean moons of Jupiter. It was discovered by Galileo Galilei in 1610, along with Europa, Ganymede, and Callisto. It is about the same size as Earth's moon, but it has a very different appearance and behavior. Io is covered with hundreds of volcanoes, some of which are active and erupting constantly. It has the most volcanic activity of any object in the solar system, producing more than 100 times the lava that Earth does. But why is it so volcanically active? The answer lies in the gravitational tug-of-war between Jupiter and its other moons. Io orbits very close to Jupiter, about 420,000 kilometers away, which is roughly the same distance as the Earth to the moon. But unlike the moon, Io is not locked in a synchronous orbit, meaning that it does not always show the same face to Jupiter. Instead, it rotates faster than it orbits, and as a result, it experiences tidal forces from Jupiter and its other moons. These forces stretch and squeeze this moon, causing it to heat up and deform. This process is called tidal heating, and it is the main source of Io's internal energy and volcanism. Tidal heating also affects Io's surface and atmosphere. The surface is constantly changing due to volcanic eruptions, which create new lava flows, mountains, calderas, and lakes. The surface is also very colorful due to the different minerals and compounds that are present. For example, Io has a lot of sulfur and sulfur dioxide, which gives it a yellow, orange, and white appearance. It also has a thin atmosphere, mostly composed of sulfur dioxide, which can freeze and sublimate depending on the temperature and sunlight. The atmosphere also produces volcanic plumes, which can reach heights of hundreds of kilometers and form a torus around this moon. Io is not only a volcanic moon, but also a magnetic moon. It interacts with Jupiter's powerful magnetic field, which induces electric currents and magnetic fields in its interior and surface. These currents and fields generate radio waves and auroras, which can be detected by spacecraft and telescopes. Io also strips away electrons from Jupiter's magnetosphere, creating a plasma wake behind it. This plasma wake can affect the other moons of Jupiter, such as Europa, which may have a subsurface ocean that could harbor life. As you can see, Io is a very complex and intriguing moon, with many features and mysteries that we still don't fully understand. That's why scientists are eager to study Io and learn more about its geology, volcanism, and interactions with Jupiter. And that's where Juno comes in. Juno's main goal is to study Jupiter's structure, atmosphere, magnetosphere, and moons, and to reveal the secrets of the giant planet's origin and evolution. It orbits Jupiter in a highly elliptical orbit, which takes it close to the planet's cloud tops and then far away from its intense radiation belts. Juno's orbit also allows it to fly by some of Jupiter's moons, such as Io, Europa, Ganymede, and Callisto. On Saturday, December 30th, 2023, Juno performed a close flyby of Io, the closest that any spacecraft has made in over 20 years. It came within roughly 930 miles, 1,500 kilometers, from the surface of Io, which is closer than the orbit of the International Space Station around Earth. The spacecraft used its instruments and sensors to collect data and images of Io during the flyby, which will help scientists learn more about the moon's geology, volcanism, and interactions with Jupiter. One of the instruments that Juno used was the Juno Cam, a visible light camera that takes stunning pictures of Jupiter and its moons. It captured several images of Io during the flyby, showing its surface features, volcanic plumes, and atmosphere in unprecedented detail and resolution. JunoCam also took images of Io's night side, which revealed the glowing lava flows and hotspots on the moon. These images are not only beautiful, but also informative, as they can help scientists map Io's volcanic activity and understand its thermal evolution. This flyby of Io was not only a scientific opportunity, but also a technical challenge and a risky maneuver. Juno had to fly very close to this moon, which exposed it to the moon's gravity, radiation, and dust. It also had to fly very fast, at a speed of about 130,000 miles per hour, 210,000 kilometers per hour, which gave it only a few minutes to collect the data and images of Io. It also had to fly very precisely, following a carefully planned trajectory that avoided any collisions or perturbations. Juno's team had to prepare and execute the flyby with great skill and accuracy, and they succeeded in doing so. Juno's flyby of Io was a remarkable achievement, and it was not the last one. It will perform another close flyby on February 3rd, 2024, at the same distance, and it will collect more data and images of the moon. Juno will also fly by Europa on September 29th, 2024, and by Ganymede on December 20th, 2024, and it will study these moons as well. Juno's mission is scheduled to end in July 2025, after completing 35 orbits around Jupiter. The new images of Io taken by Juno are not only stunning, but also significant. They could change our view of this fascinating moon, and they could reveal new insights and discoveries about its geology, volcanism, and interactions with Jupiter. Let's take a look at some of the implications and significance of the new images. One of the implications of the new images of Io is that they could help us map Io's volcanic activity and understand its thermal evolution. It has hundreds of volcanoes, some of which are active and erupting constantly, and some of which are dormant or extinct. By comparing the new images of Io with the previous ones taken by other spacecraft, such as Galileo and Voyager, we can see how its surface has changed over time, and we can identify the locations and intensities of the volcanic eruptions. We can also measure the temperatures and compositions of the lava flows and hotspots, and we can estimate the heat flux and the magma supply of Io. These measurements can help us model this moon's internal structure, subsurface magma ocean, and volcanic processes, and we can learn how Io maintains its high level of volcanism and how it evolves thermally. Another implication of the new images of Io is that they could help us study its atmosphere and its volcanic plumes. It has a thin atmosphere, mostly composed of sulfur dioxide, which can freeze and sublimate depending on the temperature and sunlight. Io's atmosphere also produces volcanic plumes, which can reach heights of hundreds of kilometers and form a torus around Io. By analyzing the new images of Io, we can see the shape, size, and density of its atmosphere and its plumes, and we can determine the sources and sinks of the sulfur dioxide gas. We can also measure the pressure, temperature, and composition of, and compare it with the models and predictions of the atmospheric dynamics. These measurements can help us understand how the atmosphere is affected by the volcanic eruptions, the sunlight, and the plasma environment. The new images are significant because they could reveal new insights and discoveries about this fascinating moon. They could also help us answer some of the open questions and future directions for the research on Io, such as, how does Io's volcanism vary over time and space? And what are the factors that control it? How does the atmosphere evolve and respond to the volcanic eruptions, the sunlight, and the plasma environment? How does this moon compare and contrast with the other moons of Jupiter, such as Europa, Ganymede, and Callisto? And what does it tell us about the diversity and history of the Jovian system? These are some of the questions that Juno will try to answer in its next flyby of Io on February 3rd, 2024, and in its other flybys of the other moons of Jupiter. We hope you enjoyed this video and that you learned something new and interesting about Io, the most volcanic moon in the solar system. Thank you for watching, and stay tuned for more videos on the amazing discoveries and adventures of Juno and its exploration of Jupiter and its moons.